If I say rational, what do you think of? You know what? A ratio, it has the word ratio in it. What does ratio mean? Fraction. We're solving equations that have fractions in them, essentially. So let's take a look at one. I told you to solve this equation. Alright, we do need to be a little bit careful when we're looking at these rational equations because in a fraction, what's the one thing that can never happen? The denominator cannot be, what's one thing? You can't have 0 in the denominator, right? If you divide by 0, your calculator tells you domain error. What would make my denominator 0 here? If x is 1. So a lot of times when I'm solving these, I kind of make myself a note. Right now, I know x cannot be 1. Because if x turns out to be 1, this whole fraction is something divided by 0, and we can't do that. My other denominator is 2. Does 2 ever equal 0? No, so I don't have to worry about that one. Alright, there are different options for how to solve this. Option 1 is we keep the fraction and we work with it. Option 2 is get rid of the fraction. Do you guys like fractions? No? How about we get rid of them? Okay? When you're doing that, you kind of need to watch your terms. I'm going to rewrite my problem just so I have a little more space. You don't have to, but I want to show you exactly what I'm going to do here. Right. This first denominator is 2. The opposite of dividing by 2 is multiplying by 2. But if I do it on one term, I have to do it to every term. Because in an equation, it has to be equal. You have to do it to both sides. So I'm essentially taking everything on both sides, multiplying it by 2. If I multiply by 2, these cancel out. Did that get rid of all of my fractions? No. What else do we have on the bottom? X minus 1. So if I want to get rid of that, I have to take it times x minus 1. But that means I need to take every term times x minus 1. Now those go away. Have I gotten rid of my fractions? Yes. So what I'm left with, and you don't have to write this step out, but I'm doing it just to show you. In the first one we have 2x minus 3 times x minus 1. Second one I have 2x times 2. Over here, x times 2, that's 2x times x minus 1. I looked at what canceled out, and this is what I have left. Is this an equation that we could solve? What would I need to do first? Start multiplying everything out. So if I FOIL here, we have 2x squared minus 2x minus 3x plus 3 plus 2x times 2 would be 4x. Over here, if we distribute, we get minus x. Okay. Combining like terms. So we have 2x squared, negative 2x, negative 3x, and positive 4x. What's that give me? Plus 3 equals 2x squared minus 2x. What would you do now? subtract my 2x squared. Lucky for us, that cancels out. So I have negative x plus 3 equals negative 2x. I can add my x over. Divide by negative 1, and x is negative 3. Did I lose anyone there? At the very least, at this point, you have to make sure that the bottom won't be 0. The denominator won't be 0. Now, at the beginning, we said x couldn't be 1. Did we get 1? No. So 3 is fine. If this were a test and you really wanted to make sure you hadn't made a mistake, what would you do? Plug it back in. It should work. If I put in negative 3, get negative 9 over 2 plus negative 6 over negative 4. So then you get negative 12 over whatever. But you can plug them back in and check. Okay? You have to make sure the denominator won't be 0. As long as the denominator isn't 0 and you didn't make a mistake anywhere else, it should work. But you can always check them by plugging back in. Do I need to show you guys how to plug them back in and check, or everyone knows? Okay. Let's try this one. What can x absolutely not be? Can't have 5. Okay, that's my domain. Any other number is fine. How many terms do we have? 3. So whatever we do, we have to multiply all 3 things. If I want to cancel this denominator, we have to multiply by? Take every term times x minus 5. If I do that, these x minus 5's drop, and they leave me with x. I have a 5 times an x minus 5. And over here, the x minus 5's drop. So there's nothing else I need to multiply by. That got rid of all of my fractions. So now we just solve this. X is 5x minus 25 equals 5. That's 6x. If I add over my 25, equals 30. Divide, and x is 5. But x can't be 5. So what does that mean? No solution. And why can't x be 5? That makes the denominator 0. We cannot divide by 0. Alright. So far, so good? Let's try a more interesting one. So, have a denominator of x minus 2. Have a denominator of just plain x. You guys have any suggestions with this? Factor it. We don't want to make the problem harder than it already is. If I just go through and say I'm going to multiply by all my denominators, that's fine, but we might be creating a more complicated problem. If I factor it, I can make sure that I'm multiplying by the least common denominator and not having bigger things to factor and solve later. How would you factor x squared minus 2x? So what can x not equal on this problem? 2, and 0. 2 would make x minus 2 0, the plain x is just the 0. Alright, so if I want to get rid of this one, I have to multiply by x minus 2, so that means everything gets an x minus 2. That cancels this denominator and half of that one, but is this enough? No, we still have fractions. So now what do I have to multiply by? So everything gets a plain x. And these drop. And those drop. The first one I have 3x plus 2 times x. This one I have 1 times x minus 2. And over here everything cancels except my negative 2. This is 3x squared plus 2x plus x minus 2 equals negative 2. Combine my terms. It's a quadratic, we always set those equal to 0. What happens if you add your 2 over? They cancel. So we have 3x squared plus 3x equals 0. What would I do there? Take out our 3x. That leaves us with x plus 1. Okay. So you set each of those equal to 0. And we get x to equal a 0 and negative 1. Are both of those possible? No. We said at the beginning that x could not be 0 or 2. So does that mean it's no solution? No. It just means you throw out this answer, but the negative 1 still works. I want you guys to try a problem. Okay, first step is to do what? Factor. So we have our negative 4 over x minus 1, positive 4 over x plus 1, negative 8 over x squared minus 1, that's difference of squares, x plus 1, x minus 1. So,
negative 4x.
Thank you. At this point, what can x not equal? We're making ourselves a note of that. So to cancel this, we need to multiply by x minus 1 to everything. So those cancel, and these cancel. But all of the fractions aren't gone yet, so we also need x plus 1 for everything. Those cancel and those cancel. It's up to you if you write this next step. I usually do just to make sure everybody's on the same page. This is what I have left after I've canceled. So if we distribute, we get negative 4x squared minus 4x plus 4x minus 4 equals negative 8. These drop out, so you have two options. Did you guys bring over the 8 or move the 4? Okay. So if you brought over the 8, what'd you do now? Okay, you can either divide on both sides or factor it out. Does negative 4 ever equal 0? No, so it doesn't give us a solution. X squared minus 1 equals 0. So you can add over your 1. But if you add a square root, what do you have to put with it? Okay, so we get positive and negative 1 for our answers. But we started this problem by saying x can't be positive or negative 1. So what does that mean? No solution. All right. Any questions do is start the second type of equation that we're going to talk about today, but I'm not going to get all the way through. So I'm going to do maybe 2 examples and we'll pick up there tomorrow. So let's say I gave you this one. This is a radical equation. It has a square root, cube root, fourth root, some sort of radical inside it. If I just gave that to you and told you to solve it, what do you think you would do first? Okay, let's get the cube root by itself. So we can add over the 2. Okay, we are trying to solve for x. So we have to get the x by itself. What is the opposite of a cube root? Cube. So we can take each side to the 3rd power. A cube root and a cube would cancel one another out and just leave us with 2x minus 4. But 2 to the 3rd power is, so we add over our 4, divide, and we get 6. Always a good idea to check on these problems. When we have square roots, a lot of times squaring can give us extra answers that don't actually work. So when you check it, you put it back into the original and just verify. I'm not going to make you write it out and show me all the work for checking it. So if you need to use a calculator or whatever, that's fine. But make sure you are checking because we will get extra answers sometimes. If I put that in, 12 minus 4 is 8. Cube root of 8 minus 2, 2 minus 2 is 0. Is that what it was supposed to equal? Yes, so it does work. Let's try this one. Okay. The square root is by itself. How do you get rid of a square root? So, when you square, you have to be careful. Whatever you're doing to both sides of the equal sign. So when I square, I'm not squaring each term, I'm squaring this entire side. A square root and a square cancel, and that gives me an x minus 1. But how do I do x minus 7 squared? Yes, we have 2 of those. So we have to think of that as writing it twice and FOIL. So if I did that, I get x squared minus 7x and minus 7x would be minus 14x. Negative 7 times negative 7 is positive 49. All right, now what would we do? Yes, you always want your quadratics to be equal to 0. So let's subtract our x and add our 1. That's x squared minus 15x plus 50. What multiplies to positive 50 and adds to negative 15? So x is 5, 4, 10. So now, when we check those, we are putting it back into the original. So if I put in a 5. 5 minus 1 is 4. Square root of 4 is, the square root would be a 2. Does the square root of 4 equal negative 2? No. So that one doesn't work, which means 5 doesn't work. If I put in a 10. I get the square root of 9 equals 3. Does that work? Yes. So 10 is the only answer that works here. It's possible that you get two answers and they both work. It's possible you get two answers and neither one works. So you have to make sure that you are checking. Questions here? Let's go ahead and stop there for today. So these problems, I am going to add to this probably tomorrow. We're not done with the section yet. So the first ones, really the 7 through 23, EOO. Does anyone know what I mean by that? Every other odd. I do this a lot. So that means you do 7, you skip number 9, you do 11, skip 13, 15, 19, 23. If you would prefer to write out the individual numbers. So the first 5 are all the rational ones, and then the next ones are radical problems. We will do more radicals tomorrow, and then add some more problems to